Okay, Chapter 2, Section 6 is looking at, specifically looking at percentages, and mixtures are going to come in not with today's lesson, but with tomorrow's. So what we're looking at today is specifically percentages and how it pertains to money, all right? Now, if you haven't noticed, this slide has been popping up pretty much every time this chapter, so I suggest you pause the video now. Make sure you write this in your notes if you have not already. So when you're solving percent equations, what you need to think about is you need to think about the overall idea of what you're going to be looking at. So what you need to do and what you're going to want to be adding to your notes in this situation is a general formula in dealing with percentages. All right, so when you have percentages, you have three parts. You have the total amount, you have the percent, and you have whatever you started with or your base. All right, so you can have that represented by A equals P for your percent times your base. You're going to want to think about it in the sense of a formula because you're going to be seeing this more than once. And it's going to help you to have a formula to work off of, because without it, you're kind of going to be guessing a little bit on certain things. So you're going to want to copy down this formula specifically so that you can work with the questions as they come. So there are a couple of different ways that you'll be seeing this. All right, in some questions you're going to have a unknown amount. All right, where your A is what you're solving for. In which case, the example that they give here, you have 10% times 500. All right, and that's your base. So you don't know what the total amount is. So in that case, you would have to multiply 500 by the 10%. All right, and one thing that you need to remember, and you should know this already because I know that this was part of your review, is that any percent is really, when you're doing it in math, going to come out as some kind of a decimal. Okay, so in this case, if you have 1%, it's going to come out as a decimal of 0.01. And that's because 100% equals 1. All right, so anytime you have a percent, you're going to be multiplying it or dividing it by 100 and moving that decimal point over those two spots to turn that into a decimal. So make sure when you're solving for percentages, you don't multiply it by, in this case, you wouldn't multiply it by 10. In this case, you would be multiplying it by 0.1 or 0.10 for that 10%. All right, if you don't know what your base is, so that's the number that you're multiplying that percent by. When you don't know the base, if you have your amount is 50, your percent is 10%, and you're not really 100% certain what the base is, and they're asking you to solve for that, you want to do that out. Okay, your other option is you might not know what that percent is. So you would have your amount, you would have an unknown percent, and you would be multiplying that by your base. Okay, another way that you can write this, and this is what I would suggest doing, write these out in formulas now. So when you have your amount equals your percent times your base. Okay, what do you do if you're trying to solve for base? Well, if you look over here, to get the b by itself, you would divide both sides by that percentage. So if you're looking for your base, your formula would be base equals your amount divided by your percent. If you have your percent and you're trying to get, you need to try to solve for percent. To get the percent by itself, okay, your p over here, you divide it by your base. Okay, so these three formulas will be helpful for you to have in the future. So what you're looking at with this is your amount. Your amount is unknown. Your base is unknown. And your percent is unknown. Okay, that's when you're going to be seeing these three things. So pause this for a minute if you haven't been writing this down with me and write those down. So some examples of this in practice. If you have, what is 9% of 65? All right, the reason why I'm going, even though the answer is right here on the left, the reason why I'm going to walk through this is because I don't want you guys to make some mistakes that I foresee you making. All right, the what is telling you that you have an equation. Okay, so what is that? What is going to be what you're solving for? 9% of, if you guys remember from your word problems, of is the same as multiplication of 65. Okay, now what this walks you through is it does change that to a decimal for you. All right, so the decimal for 9% would be 0.09 times 65, and that's going to equal your x. All right, so when you do that out, you get 5.85. Okay, another example. 36 is 6% of what? 36 is 6% of what? So what you have in this case is you're given your amount, and because your 36 is 6% of what? You see the pattern here? You have your number is, or in that first example, what, that's your x, is 6% of what? So you're looking for your base. So if you come over here and you use this equation to solve this next problem, you would end up having, all right, your b is what you're solving for, right? And you have your amount, which is 36, over your percent, okay, coming back up here, a over p, which is 6%, and you write out 6% as a decimal of 0.06. You do that math out, and you would get 600. So your base is 600. Okay, so come back over here. 24 is what percent? So your original equation would be 24 is what percent of 144. Okay, so you're looking for percent. You have your formula here. Percent equals your amount over your base. Okay, and when you do that out, you're going to get a repeating decimal. And what you would do with a repeating decimal is, if you have a repeating decimal, in this case, of 0.16 with the 6 repeating, that would be a 16%. And when you have 0.6 repeating, so if you move this over, you would have 16.6 repeating because of this repeating that was here. That repeating is going to transfer over till after the decimal. And you guys should remember that 0.6 repeating as a fraction is going to be 2/3. So your solution to this would be 16 2/3%. So where you're going to be using this in a regular basis, or a real world example, is when you're dealing with discounts or when you're dealing with markup prices. Okay, so when we look at a discounted amount. Your discounted amount is going to be a certain percentage of a whole total. So in this word problem, you have Julie bought a leather sofa that was on sale for 35% off of the original price of $1,200. What was the discount and how much did she pay? All right, so we have actually two questions here. They want your discount and they want how much she actually paid. So this is going to be a two-step problem. All right, now I would suggest writing down this equation as well. You're going to be seeing percentage questions in the future and you're going to want to have this. So you're going to want to write down a formula of your discount is equal to the rate of the discount, or your percent discount is the same as your rate, times your original price. Okay, so your discount equals your percent times your original price. So in this case, you're given some of that information. Okay, so you are told that she pays 35%, there's 35% discount off of the original price of $1,200. Okay, and you are looking for whatever that discount was. So when you do 0.35 times 1,200, sorry, you would end up with your discount price is going to be, make sure you have the units on here, $420. That's the discount price. That's not what you paid. That's the amount that's off. Okay, so the important thing is you need to make sure you answer the second part to that question. And the second part to that question is going to have another formula where your total amount, or your amount paid, is going to equal whatever the original price was minus your discount. Okay, so your original price minus your discount price. So you're given the original price in the equation. Your original price was the $1,200. You just found the discounted price of $420. So how much money did she pay for this sofa? All right, she paid the $780 for the sofa. Okay, so this is a two-step problem. Make sure when you're doing these, you're answering both questions. So you have the amount that she paid and then the amount that she was discounted. All right, so markups. So markups are going to be, like in this example, if there's a tax, that's the most common example you're going to see. We don't have that problem in New Hampshire that much. We don't have a sales tax, but other states do, and we do have a food sales tax. All right, so what you're going to have here is you have this example where someone's going out to dinner and he has a total amount of $66 that he can spend. All right, he has $66 total that he can spend. All right, so if you're going to spend money on a meal, you have your cost of your meal, okay, which we'll have represented as X. But he wants to tip whoever this person is going to be, that's going to be their waitress or waiter. He wants to tip them 20%. All right, and when you tip somebody, it's 20% of your cost of your bill. So you have your original, the amount you spend on your food, your tip is going to be the percent times the money you spent on your food. Okay, so when you have this, you now need to solve for X. Okay, so you have to get x by itself. You can combine like terms. In combining like terms, you have a 1, an understood 1 in front of that x. So you have 66 equals 1.2x. You need to get x by itself. You divide both sides by 1.2. Okay, and you would end up with $55 that he can spend on the food alone. All right. And there might be a second step where it says, all right, so if you spend that much money, how much was the tip? And you would kind of just plug in the $55 you get here up here for X. So you would take the 55 times 0.2, and you would get the amount that he would have spent in in the tip for that waitress. Okay, so what you're going to end up seeing is a lot of real-world examples where you have tip that's coming into play, and other real-world examples where you have discounted amounts. You'll go into a store a lot and you'll see that there's a certain percentage taken off of a sale item, so it's 25% sale. So at that point, how much did they actually, are they actually going to spend? Okay, so that should be all you need for this. And you should be all set to get going on tonight's homework.